Okay, guys. So let's start with the today's push contest discussion. Okay, so let's start with the first problem of this contest. In this problem, you are given with you have a prize wheel divided into L sections numbered from 0 to L minus 1. The sections are arranged in a circle. So after section L minus 1, number continues again from the section 0. Initially, the prize pointer is at section A. Each time you spin the wheel, the pointer moves exactly B section forward. That is, after one spin, the pointer moves from section A to section A plus B model. After two spin, it goes to A plus B, A plus 2B model, and so on. You may spin the wheel any number of times. After you stop, the section where the pointer finally lands determine your price. And you are asked to what is the maximum price you can obtain. Okay. Okay. So, yeah. Now you are given with let's say a wheel where numbers are like 0, 1, 2, 3, and up to L minus 1, and you start with any point A and you are given a value B, so that after each round the pointer moves B points ahead, correct? And you are asked after any number of operations what is the maximum price that you can obtain. Okay, the maximum price that you can obtain, how will we find that? So first start like this. You are at point A. After first operation you get to point A plus B. After second operation you got to point A plus 2B, and so on. Right? Let's say after K operations I reached the maximum price. So how will I write this? Can I write this like A plus K into B model? Is this, you can expand it like A plus B plus B plus up to K times, correct? Can I write it like this? Yes. Now, now how will I find what is the optimal value of K so that I go up to maximum price? You can either iterate over the values as n is 5000 and our constant is 5000. You can just iterate some number of times. Let's say for the safer side you can iterate up to 200 times and you will get the maximum answer. Obviously, go with like A plus B, then check A plus 2B, then check up to you can go up to 5000 times or any number of times. You will get at some point you get the right answer. But can I generalize this formula? Look, let's take some examples and we will get to the point. Let's say there is a strip of length 10 and I start with point, let's say 0, and my B is 3. Okay, so so my jumps will be like 0, 3, 6, 9, 12. When modulus with 10, it gives us 2, then 5, then 7, then sorry 8, then 11. When modulus with 10 gives us 1, then 4 and 7, and then again 0. And this will continue. The cycle will continue again. Correct? So If I rearrange this, can I see something like this? I get every number from 0 to L minus 1, and my maximum price is 9, right? Let's say some other B. Let's take some other B. A is still 0 and B is 2. Now let's see what happens. You start with A is 0, then you jump to, then again 2, then again 2, and then after 8 you get 10, and when modulus with 10 it gives me 0, and the cycle will continue again from here. So this time my answer is not, maximum answer is not 9, this time it is 8, right? Now can you let's take one more example. B is equals to 5 for the same L equals to 10 and A equals to 0. This time I start with 0, I go to 5, then I go to 10, again modulus with 10 gives us 0, then 5, and continue. This time my maximum is just 5, correct? If you see all these three examples, you will notice something, that the difference between all these consecutive points, here it is 1, here it is 2, and here it is 5. So what does this signify me? Like for 10, 0, 3, I get 1 as difference. For 10, 0, 2, I get 2 as difference. And for 10, 0, 5, I get 5 as difference. Can I say this 1, 2, 5 is just GCD of L and B? Is it? Right? This is just GCD of L comma B. Now, if this is GCD of L comma B, it means that I can jump from any particular point A to GCD L comma B to some point. So this also means that from the last point, which is 10, I can jump back at point GCD L comma B, because after that the cycle will continue again, right? So currently my answer will be like L minus GCD of L comma B. Okay. Now A can be start from any point. If I had A like this, 1 and then 3, or let's say 2, B2, A1 and L10, then my jumps will be like 1, 3, 5, 7 and 9. This time I got 9, right? Two problems and 8 wrong submissions. Yeah, a lot of wrong submission in this. Okay, so this time I got 9, which means this difference is still 2, but I start with A equals to 1, that's why I get 9. If I start with A equals to 0, I got 8. So I can just add A mod L, or you can say GCD, right? Because after A equals to 3, yeah, sorry, A equals to 2, the cycle will continue again. 2, 4, 6, 8 and 0. I will again get 0. The still maximum will be 8. So my final answer will be this. So I can write this in a formula directly. Let me show you. So here I take LAB as input, and my final formula is L minus GCD of LB plus A modulo GCD of LB. right? Is this clear till now? Should we move to the next problem? Okay, right. This is an easy problem. So let's see what it is saying. You have an array A of n strings A1, A2 up to An, each consisting of lowercase English letter and an empty string S. In the ith step, you should do one of the following. Add AI to the beginning of the string or add AI to the end of the string. For example, if the ith step S is equals to ABA and AI equals to BBA, after the ith step, S will be equals to ABA double BA or BB double A double BA, right? What is the lexicographically smallest string S that you can reach after n steps, right? So let's see. Yeah, in this particular problem, you are given with the empty string currently, okay, and there are some consecutive strings. Uh, let's take the first example. This Amir, Hima, Amin, and Nima. Amir, Rima, Amin, Nima. Okay. So currently my string is empty, and at the ith step I have to add the ith string in the start or in the end. So either I can do AI plus S or I can do S plus AI. Any of these two operations. Okay. So currently I am at the starting index. So adding from anywhere left or right, it will be same. So my currently the string will be Amir. Okay. In the next iteration, I get Rima. So is it better to add Rima in the first place or in the last place? It is better to add Rima at the last place because at in the my starting string is A, and if I add Rima in the first place starting place, it will give me R as the starting point. So this will make my string lexicographically larger than previous, right? So to do this, I can do one thing. I can make two temporary strings T1 as Amir Rima and T2 as Rima Amir, and check which of these is lexicographically smaller. This one is smaller, so we will take this to the next iteration, which is this. I mean, now I can again do the same thing. I will make two temporary strings T1 as Amir Rima and Amin, and second is Amin Amir and Rima. Now check which of these is lexicographically smaller. This one is lexicographically smaller this time. So we will move forward with this string to the next iteration, which is Nima. I will again make two different strings. Amin, Amir, Rima, Nima. T2 is Nima, Amin, Amir, Rima. Which of these is lexicographically smaller? T1 is lexicographically smaller this time. So my answer will be this. So to do this, you can just basically implement directly. You don't have to think a lot in this problem. As you can see, I have taken L and the string as input. Then my starting string is v0 because adding from anywhere it will still give the same result. Then I have iterated over the array. Then the string a will be is equals to my first temporary string, which is equals to bi plus answer. My string 2 over the temporary string 2, which will be equals to answer plus bi. If a is less than b, lexicographically less, then my answer is a. Else my answer is b. Just count the answer directly. So this is the second problem. Is there any doubt in this? It was a quite easy problem for B. Okay. Is there any doubt? No. So shall we move towards the third problem? How many of you were able to solve the C? It was quite typical. I got 8 wrong answer in that. Hmm? None? Okay, so let's move to the problem C directly. Okay, in this problem, we are given with Oersted thinks that the usual way of factoring number is too mathematical. So he invented a new notion called XOR factorization, which is more computer science like. For a given integer n, a sequence of integers a1 to ak with 0 to ai to n, matlab all the integers are reside in the range 0 to n. For all I is called a XOR factorization of n if and only if a1 XOR a2 XOR a3 up to ak is equals to n. Now where XOR operation denotes bitwise XOR operation. Okay, you are given with integers n and k. Find the XOR factorization of a1 a2 up to ak that maximizes the sum a1 plus a2 plus a3 up to ak. It can be proven that under the problem constraint, a XOR factorization always exists. Okay. This is a little complicated for some people who don't know about bits. So you are given with a value n and a k, right? And you have to break n into this form, correct? Now there is a property of XOR where XOR states if a number is XORed, you know, even times, the value is 0. And if XOR is done odd times, value is same, right? So what is the maximum value of the sum as my a I is in the range 0 to n? The maximum value is n into k. Yes or no? Just adding n plus n k times, right? Now at what k, if I XOR all these n values, at which k I will get n again. What should be the k? K must be an odd integer, correct? If k is odd, then I will get XOR as n, and my sum will be maximum, which is n into k, correct? Now, so for point, if my k modulus 2 is 1, we can just print n k times. Instead, did for odd k, I will be n, and for even k, k minus 1 would be n. Give the wrong answer in pretest. Yeah, it gave. Even if I know what you were thinking, like I was also thinking the same thing, that if we take, like, if k is odd, if k is even, then I can just print k minus 2 n's, and then I, for the last two values x and y, this XOR should be equals to n, right? So I can just, even I just brute forced x and y, like I created a loop for x, and then I calculated y as n minus x, but this still gave you wrong answer, right? I was not able to make this problem during the contest, but I made it after the contest. So the real intuition that you should get is quite complicated. Is, let's say n has some bit. Let's say n is equals to some bits like this, right? So for every one, there the k is even. Please remember this, k is even. So to get one at this place, we can place every other value, or every k minus 1 bit as 1, or sorry, every k minus integers as 1, and exactly one integer as 0, right? So this is odd, and I just said doing XOR with odd number of elements gives the same single element again. So I will get 1 again, right? And uh, I have to keep 1 0 because I need to make 1 here, and I need to make k minus 1 as odd. So for every bit which is set in n, I have to make k minus 1 elements set at the same bit, and a single element set at the 0 bit. Okay, so this was the intuition for on bit. If my bit is 0, so I can write it here. If bit is set in n, then we have to set k minus 1 element of that bit as set, and exactly one element with bit 0. Okay. Now if bit is not set in n, I am talking about 0. Now remember, k is even. We can set all the values in, like we can set all the k elements, right? Is this clear? This was the intention of this problem. Like if let's say n is 5 and sorry, k is 5 and my n is something like this, right? This is my bit set of n. So I need to make 5 integers. Oh, sorry. K is 6. For even, I need to make 6 integers. So let's see. My first integer will be I can set the one bit here, right? For the second integer, I will set again, set again, set again, set again, and for the sixth integer, I was not set. So after doing XOR of this whole set, I will get 1, right? Here it is 0, so I can set all the bit as 1. I will get 0 here. Here it is 0 again. I will again set all the bits. I will again get 0. There again the bit is 1. So I will set 1, 1, 1, 1, 1 and 0. I will get 1 here. Again 0. I will set all the bits. I will get 0 here. There are 2 ones. So I will do the same thing again. And here 0, 0. So as you can see, after doing XOR of all the 6 numbers, I will get the n again. But this time the values of this is maximum. As you can see, this gives us how many bits are there? 1, 2, 3, 4, 5, 6, 7. So 2 raised to power 8 minus 1, which is 255. Correct. So 255 plus 255 plus 255. And this is 1, 2, 4, 6, 8. Oh, sorry. 1, 2, 4, 8, 16, 32, 64. This is 40 and 104. This is 104, right? 40 and right. Okay. So this time the sum is maximum. As you can see, n was 1, 2, 4, 8, 16, 32, 64. So n was 72 plus 2, 74 plus 1, 75. Right. So n was 75. And if you do as you were suggesting, then you would have get 75 into 6 minus 1 plus 0. And this time I am getting 255 into 6 minus 1 plus 104. Which is larger? This one, as you can see. So this was the current intuition of this problem. This was quite hard to think, like I was not able to implement this on time. Okay, so from solution all the elements should be less than n. Oh shit, oh I forgot I just forgot, sorry. I just made a mistake here. Okay. Right. Yeah, every element should be less than n. So I just forgot this. For each bit you can set all these as 1, and then for 0 you can set all the bits as 1, but at some particular point it will exceed the value of n. So you have to keep in this mind, right? I can set this as 0 also. and for this same I will repeat. Now for another one, I choose to place 1 here, and I will choose to place 0 in this place. So my value will be like this. Again for 0, put the value as 0, and for 1, you can choose to place again at some place, like I can choose 0 to place here or here, depending on the which bit is on. So if I place 1 here, 1 here, 1 here, 1 here, 1 here, and same goes to for this, 1 here, 1 here, 1 here, 1 here. So this will give us a maximum answer for this. Coming to the solution, what code? So this was the code for this problem. As you can see, if k is odd, you can just output n k times, and you made a I have made a array k which tells me which bit is on for the k elements. I have to take k elements, like k minus 1 bits is on. I have taken the count which particular bit I am currently standing at, going from MSB to LSB. Current bit value, I've chosen the current bit value. If it is set, then and count is less than k, so I just increase my count. I have placed the value here, and for all the other elements, I just go iterated over j from 0 to k, and I have checked if the bit is not set in that particular position. I just set the particular bit. Else the bit is unset, I will check how many elements are left that can be set. Then I iterated over those left set elements, and I just set those elements. You can then output the array. I just messed up in that. I just forgot that it should be less than. I got into the flow. If it is 0, you have to set as many elements as you can as one, keeping in mind that uh, the value should not exceed n. Like you can set this value also, but then this XOR will be 1. You have to set some value here 0, and this update is here. Is there any problem with this? Shall we move towards the D problem? Okay. Okay. In this problem, you are given with n different integer point. X1 is less than x2 is less than x3 up to xn on an x-axis plane. For each I 1 to n, you have to pick a real value of Ri greater than 0 and draw a disk with radius Ri at the center of xi such that no two disks overlap. You want to choose a value Ri in such a way that the number of tangent pairs of the disk is maximized. You have to find this maximum value. We say that two disks overlap if the area of the intersection is positive. In particular, two outer tangent disks do not overlap. Okay. So in this problem, what you are given with the x-axis, and there are some points like this. And from each point you have to choose a value Ri and draw a circle like this, right? And after drawing the circles, you have to count how many circles coincide at some point. Like there is a one particular point that both the circle touches. For this particular problem, answer is 3, right? I can take another example, like these 2 points, these 2 points. So for this, you draw a circle like 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 this, right? Here it touches at these 2 points. So my answer is 2 for this. You have to find, you can just uh, change the problem statement as draw circles from xi with radii ri such that no two circle overlap and count the number of points circle T touch each other. You have to maximize this. Okay. So to maximize this, what we can do, let's start with something. So these are 2 points, let's say x1 and x2, and I have chosen some radii r1 for this. So this will be my circle, and I have chosen some radii r2 for this, and this will be my circle. Correct? They touch at this particular point. So I say that x2 minus x1 is equals to r1 plus r2, which is distance. This x1 and x2. If I take this distance, this particular distance, you can see it is equal to sum of both two radius, and which is equal to distance between the two centers of the circle. After then I can just rearrange it like this. R2 is equal to distance minus r1, or I can write is ri plus 1 is equal to d minus ri. Can I write it like this? Look, if I fix ri, then ri plus 1 will also get fixed, or not? If I fix this point, if I take this as constant some k, then ri plus 1 will also be a constant, let's say k2. And this formula operates over all the possible radiuses. So r2 or ri plus 2 will be equals to d minus ri plus 1. So if this is constant k2, this will also be a constant k3. As you can see, if ri is fixed, then ri plus 1 will be fixed, and ri plus 2 will be fixed, and so on. So this makes a chain reaction. Okay, keep this in mind. Okay, this makes a chain reaction. So when this chain breaks, Like if radius is positive, then chain can continue. But if radius is less than equals to 0, chain breaks here. This is not a valid radius for any circle. Now, how can we do this? For this, greedy will fail, as you cannot particularly fix a particular radius and move forward with it. Like you cannot choose Ri as some 2, 3, or 4, then continue with Ri plus 1. This will give us a wrong answer. So what we can do is we can use a DP approach, right? The DP approach will be like, I will add the current radius to chain, or I make a new chain. This is correct, right? I can just add my current radius to the chain, or I can make a new chain. Okay. So I can make two states, like an offset or an onset. Offset defines my chain is break, and the value is not in my set, and onset defines it is in my set currently. Chain continues, right? So when this offset will be true, if r is less than equals to 0, and if r is greater than 0, the onset continues. So next, is there any doubt till now? Look, if we are coming from offset, which means which is not in my set currently, so we can continue. There is no need to do anything. You can just continue. Like same take no take DP, you can just no take it. But if we are coming from an on state, onset state, we have two options, right here. So we can just take the same on state, and or we can just take offset plus 1, which means I have broken this link till here and started a new link. Now, if coming to the implementation part, how will I implement all of this thing? Let's make starting offset link as 0, onset link as negative infinity, right? And range L equals to 0 and R equals to 0. This is my initialization part. Why L0 and R0? This two things defines the radius is how much they extend. Like if there are some points in my onset, there will be some radius is range in this part, like this. So R defines this particular point. That's why I've taken L and R. which defines the length of the onset radiuses. Now, what I will do next, I will just take the difference of the current x coordinates, which is x plus 1 minus xi. This is my difference of the current x coordinate. Now, as I just said, there are two possibilities, which is offset state and onset state. Let's do this again. For offset state, I can choose not to take it. So my next offset, I can write it like this, will be same as the previous offset, or I can choose to take it. When will I take, the new offset? This should be when my onset value should be greater than infinity, and my L index should be less than D, which means it should be a valid range of L to R, right? Then I can just take my next offset as maximum of next offset comma onset, correct? This is just no tick, and this is just tick. Sorry, this is no tick, and this is tick condition. I have taken maximum of both. Now, for the onset condition, there can be two possible score values. Like I can choose score one from previous offset. Let's say S1 is equals to previous offset जो था plus 1. In this particular point, L will be equals to 0 and R will be equals to D, and it will stand here. Now, I can also extend my current offset rate. So I can take score 2 as extended onset. So let's say score 2 is currently infinity. L and R is 0. So my new L will be max of 0 comma D minus R, and my new R will be is equals to minimum of or infinity comma D minus L, right? So at any particular point, if this is valid, which means they don't overlap or I'll go away from R in the right direction, then I can update my new score, which is the extended onset as onset plus 1, and my L2 is equals to new L and R2 will be equals to new R. For this, I can update here. I have to check for the particular problem when I'm adding to my current set. Then I have to check that it is a valid point or not. I can add so that in further while going in future, it doesn't cause me a problem or something like that, right? After that, I can just check which one is maximum and take that point as my answer. So that's all it. I can just show you the code of this particular problem. Right here, this is the I have taken input of x. I have taken x is x multiplied by 2 because the radius can go, in decimal points. So it is better to take 2 into a radius for a greater, you know, um, search space for our radius to work. If n is 1, the answer is 0 because there is a single circle. I made two sets as offset and onset, which defines the currently chain is break or currently chain is on. I've taken the LNR, which states that the length of the chain. Then I've iterated over all the indices. I have taken the distance as xi plus 1 minus xi. Now, this is the part where you have to take or not take on the um, not offset, which is means the chain is break. You can continue from the breakage chain, or you can continue from the previous chain uh, and on previous on chain. So either you can continue to break, or you can continue. You can extend the previous chain. So to extend the previous chain, it should not be infinity, and L should be less than D. You can take the maximum of both, right? After that, this part is for the onset part. You have two scores. Either you can continue from offset, then your L1 will be 0 and R1 will be D. If you continue from the current onset, you have to check that that onset is valid or not. For that, you have to take new L as maximum of uh, 0 comma D minus R, or and new R as D minus L. Minimum of infinity or D minus L, it will still be D minus L. And if it is a valid point L and R, then I can update S2 as onset plus 1 and L2 as new L, R2 as new R. If S1 is greater than S2, score 1 is greater than score 2, then I will update with my score 1 the values of onset. Else, I will update my onset as value of score 2. My offset will be the new offset. This is the DP. After that, you can output which is the maximum. This is particularly standard technotic DP problem with some geometric constraints. So this was the whole solution for this problem. Any doubt in this? Hmm? No? Should we move to the last problem? E. Okay. So let's move to the problem E. In this problem, you are given with in a jungle there is a lake with infinite lily pads on it. The lily pads are numbered from non-negative integer 0 to infinity. The lily pad with a number between L and R inclusively are suitable, while other lily pads are not suitable for frogs to sit on. Currently, a single frog is sitting on each of the suitable lily pad. Ostad is watching the lake and wants to reorder the frogs. To do so, Ostad can pick a positive integer x and announce it to the frogs. After hearing the number, frog sitting on the ith lily pad will jump to the point x I plus x, where XOR denote the bitwise XOR operation I XOR x. Oster like the frogs, and therefore he wants to pick the number x in such a way that all the frogs stay within the range of suitable lily pads. Help Oster by counting how many different number x Oster can choose so that no frog jump outside the suitable segment of the lily pads. Okay. In this problem, you are given with infinite range to up to infinity. And there are 2 points. there are 2 points, L and R, and between these 2 points, frogs are sitting on it. Like all at all these points, there is a frog, right? Give me a second. Let me check the live stream. Okay. From each point from L to R, there is a frog sitting on it, and we have to choose a particular point X and announce it to the frog. So the frog sitting at point, let's say AI, will move to point AI or X, and he says that this point is should also be inside this range LNR, right? So uh, I it says that if ith point is between LR, then I plus one point shall also be inside LR. Or can I write it like this mathematically? There is a set S where all the X belongs to I is or X, sorry, I is or X, it's I is or X. X belongs to some positive integer Z, and so that I belongs to L comma R, and I or X also belongs to L comma R, right? So this is my set. I have to make a set such that I belongs to L comma R and I or X also belongs to X, L comma R. I have to find this X. How many X are there? Okay. So you have to understand one thing. XOR works independently on bits. On bits, right? And when you get the problems, you have to when you need an intuition for these kind of problem, when you are given with a XOR and when you are given with a range like L to R, some of the time prefix or will work, but in this particular case, prefix or will not work, obviously. What you have to do for this particular problem, you are given with a range L and R. You have to write bits for L and write bits for R, uh, so that like some bits, and you can say, and you have to find the most significant bit where L and R are different. For example, at this in this is the most significant bit at which L and R are different. Let's take in some example. L is equals to 10 and R is equals to 29. So for this bit set will be 1010, and for this bit set will be 1110. Right. As you can see, it differs at this bit. Which bit is this? 0, 1, 2, 3, and 4. Fourth bit. So let's say kth bit, where k is equals to 4. Right? It differs as k bit, kth bit. Or I can say the point it differs at is 16 or 2 ki power 4 2 ki power k. And I can also state that all the value of x should be less than 2 raised to power k plus 1, or you write it as x should be less than 2 raised to power 4 plus 1, which is 5, X should be less than 32, right? Currently this is true. X should be less than 32. It should not exceed. Currently this is true. I'm not saying like R is 29. How can 30 will work or 31 will work? I am coming to that. Right. Now, so I can also make one more statement that at the bit k, at the kth bit, L is 0 and R is 1. That's why they are different. They differ at the kth bit, right? R bit at L position, bit in L which is in the kth position is 0 and bit in R which is in the kth position is 1, right? So I can divide my range L and R into two parts, say left and say right. And this left part will be from L to 2 raised to power k minus 1. And this is 2 raised to power k, comma, R. Or for this you can say 10 and this was 16 minus 1 which is 15 and this is 16 to 29, right? These are the two halves. In these half, all the bit at k position is 0 and all these half at the bit at k position is 1. Okay. Now, there are two cases. Case. There is a x that does not flip the bit k. As x is, we are zoring I and x. So x can flip the bit in I, right? So we are saying there is a x that does not flip the bit k, right? In I. So while zoring, the k bit does not flip. So if it is 1, it stays 1. If it is 0, it stays 0, right? Then I can also say that if it is in the right half, if I is in the right half, then it will still in the right half. And if I is in the left half, it will stay in the left half, right? Got it in here? If x does not flip the bit, then I have divided the range into two parts. The right range consists of 1 bit and the left range consists of 0 bit. So if x does not flip the bit in k, if x does not flip the bit in I at the kth position, then the right half elements will stay in the right half and the left half element will stay in the left half. Okay, right. Now we have to see some more things like if there is a value, let's say I had 10 as L, it has bits this. Can I take x is equals to 2 or greater? No, I can't take that. Why? Because at x is equals to 2, when I XOR with this particular position, it will give me 8, which is less than 10. So this is wrong. If I increase this x equals to 3, then I can just XOR with 11. Then it will still give me 8. So great, any x greater than equals to 2 will fail. Right? You are XORing with every particular frog, right? So you have to check for every x for every frog. So here x equals to 3 fail for 11, x equals to 2 fail for 10. So this means my x should be less than the lowest bit of L, which is this. As you can see, x is equals to 1. When I XOR with this, I will get 1011, which is 11. And this is inside the range of 10, 29. Right? So we have to look at this particular thing, like x should be less than the lowest bit of, we can make a conclusion here, x should be less than lowest bit of L, right? Now for the same thing I can say for R. Can I say the same thing for R? Yes, x should be less than lowest bit of R minus R plus 1, right? X should be less than lowest bit of R plus 1. For the same particular reason, as you can see, for 29, it is 1 0 1 1 1 0 1. This one. If x is 1 and y is oring this, I will get 1 1 1 0 0. This stays. But if it goes this 2, then as you can see, oh sorry, if it goes 2, then you can see it will become 31, which exceed my range 20 to 29. This exceed. So we have to check for the lowest bit of R plus 1 and lowest bit of L. R plus 1 by, because for R plus 1, which is 30, you can see this is 30 and this is 2. So you have to XOR with something less than 2. As I have shown that I have XORed with 1, it gives us the right answer. Right. So these are two particular points which need to be remembered. X should be less than lowest bit of L and x should be less than lowest bit of R plus 1. Now there is second case where x is greater than 2 raised to power k, or x flips the bit k in I when we do I or x. Right? If it flips the bit, then can you say that left part will go in the right part and the right part will go in the left part? Right? 1 will turn 0 and 0 will turn 1. Correct? Now, so to make this true, the elements in left part must be equal to elements in right part. Count of those elements in right part. Right? The range should be symmetric. Like this is my left part. This is my left part, and this is my right part. And if we are interchanging elements from this to this, so if there are let's say t element, then here should be t element also. Then only you can take all these t element here and all these t element here. If there is any extra element, you cannot take it anywhere. It will go outside the range. Right. For the range to be symmetric, then I can just state that r plus l should be is equals to 2 raised to power k plus 1 minus 1. K is the turned on bit here. Oh, the bit which is differ in both L and R. So now, what was my range earlier for 10 and 29? For my 10 and 29, my range was 10 to 15 and 16 to 29. Now, if you look, there are total number of six element is 6, and there are total 14 elements. They do not, uh, they are not similar. So we have to make them similar. How? I can choose 10 and 15, and I can just make it 16 and 29. So now this both ranges are 6, 6, 7. Now the ranges are symmetrical, correct? Now how will you do this symmetry part? You can just make a mask and check L and mask plus right R and mask is equals to mask or not. You can check this. If it does, you can find out the length S R and mask minus P plus 1. Then you can append your answer with the symmetry formula. This is the symmetry formula. Length and minus length, right? So you can just output the answer. So this is the whole problem. It was implementation is very small, but it was a hard problem. Like you need to know math and D. Okay. So this is the problem. As you can see, I have taken the L and R as input. Here, if L is equals to R, there is no point. And I have taken the XOR of the element to get the kth bit which is set. So I can just find the count of leading bit MSB formula 63 minus count leading zeros of that bit. Then I've taken the P which is 2 to the power k, the lowth bit in L and the lowth bit in R, as just I've said L and R plus 1. I have taken that from the symmetry formula again. Now answer should be minimum of these three things. It should be less than 2 raised to power k. It should be less than low bit of L, and it should be less than low bit of R, right? Minus 1 because it should be less than minus 1 to get in the range of the bits. Then I made a mask which is, if P is 2 raised to power k, then this is 2 raised to power k plus 1 minus 1, right? And I've checked if the L and mask and R and mask is equals to mask, which means the split. I have to check the split is valid or not. And after that, I have just taken the length which I will get after splitting like 10, 15 and 16, 21, which I have said the length of 6. Then I have just append my answer with length and minus length. This is symmetry formula and just output the answer. So this is for this problem. Is there anything which you haven't got? No? Okay. Okay. Not understand your last problem. Okay. What did you not understood in this problem? Like which part? I think yeah, you got till here. You might got stuck in here from this, right? Okay. Um, did you stuck here or anything about this in this formula? This formula is nothing. This is for symmetry check. This is for symmetry check. And here I found the length. What is the suitable length? For this, I have taken 6, and for because 10 to 15 is 6, and 16 to 29 was 14. So I have to take 6 as the length. So here I took the length. And here I just appended the symmetry answer, which is length and minus length. This is just for symmetry. Okay, so that's it for today. If there is anything else, you can ask. All right. Thank you.